I'm Anil Kumar, and here is a trigonometric identity to prove. The question is cos x minus 1 divided by 1 minus secant x equals to cos x plus 1 divided by 1 plus secant x. So in such cases, we could start from one side, multiply by the conjugate, and get the other side. So that is one way of solving. So what I'm trying to say is method 1 is that you could start from, let us say, the left side, right? So you could start from left side, say cos x minus 1 over 1 minus secant x, multiply and divide by 1 plus secant x. That is the conjugate of the denominator, and continue to prove left side equals to right side. That is one way of doing it, right? Now, but what we will do here is we will actually solve from both the sides. Then be kind of simpler solution. So right side for us is cos x minus 1 over 1 minus secant x. We can write secant x as 1 over cos x. So we get this as equals to cos x minus 1 over 1 minus 1 over cos x, right? Now, we can take cos x common, so we get cos x minus 1 divided by cos x minus 1 over cos x, and which is equals to cos x, right? So they cancel out and you get cos x. Similarly, if you do from right side, so this was the left side for us. If you do the right side, you get cos x plus 1 over 1 plus secant x. So we could write this as cos x plus 1 over 1 plus 1 over cos x. And that is cos x plus 1 over cos x plus 1 divided by cos x. This time, let me write this in a different way, which I think will be more familiar with you. So we have cos x plus 1. I'm just writing 1 here, and this divided by, we could write this as cos x over cos x plus 1. So now it becomes very clear that we could cancel these factors, right? So what you get here is cos x. So both sides we get cos x equals to cos x, and that is how we can show that this identity is true, right? Of course, we can start from one side and end into the other side also, but that is kind of a simpler proof which I recommend for this particular question. Thank you.